So these are the problems based on Nernst equation. So calculate the EMF of cell in which of the following reaction takes place. Ni converted into Ni2 plus Ag plus converted into Ag. So E0 cell value is given, which is 1.05 volt. Ag plus concentration and Ni plus 2 concentration also given. So what we have to do is Ni plus 2Ag plus gives rise to 2Ag plus Ni2 plus. So here Ni 0 oxidation state to Ni plus 2, Ag plus converted into Ag. So in this E0 cell value is given. E0 cell is 1.05 volt and Ag plus concentration is given. This is 0.002 m, and same way Ni2 plus concentration is given 0.160. Since it is not at 1 m concentration, we need to use Nernst equation. What is the formula for Nernst equation is E cell equals to E0 cell minus 0.0591 by n is the number of electron exchanged, log q is nothing but product ions by reactant ions. So product ions are what? These are in aqueous state: solid, aqueous and solid. So Ni2 plus by Ag plus whole power 2. So here Ni2 plus value is 0.160. You can write it as 16 into 10 power minus 2 by Ag value is 2 into 10 power minus 3. Since it is power, you can take it as square. So what you can write, 16 into 10 power minus 2 by 4 into 2 square means 4 into 10 power minus 6. So 4 ones, 4 fours, you can get 4 into 10 power minus 2 into 10 power plus 6. So which is equals to 4 into 10 power plus 4. This is the Q value which we have got. That we can substitute in this formula. So just you write here Q. So E cell equals to, how to find E cell only. So E cell equals to 1.09, it is 1.05 minus 0.0591 by 2 log 4 into 10 power minus 4 into 10 power 4. This we have to simplify. So how to simplify this? Everywhere base 10 will be. So log base 10 4 into 10 power 4, can write it as log base 10 4 plus 4 log base 10 10 power 4. Base 10 log 10 base 10. So here log base 10 4 value will be 0.602 plus, you are supposed to know log values from 0 to 10. 4 into log 10 base 10 will be 1. So what we can get, 4.602 is the resultant value for this. Then the value what we can write, E cell equals to 1.05 minus 0.02955. You can take 0.06 in the board level questions. So log base 10 value we have got it here, which is 4.602. So if you simplify this, E cell equals to 1.05 minus 0.136, which is equals to 0.914 volt. This is the answer, or this is the E cell value.
Coming to next, the standard electrode potential for a Daniell cell 1.1 volt. Calculate the standard Gibbs free energy. So standard Gibbs free energy, how do we calculate? That we can do now. So here the equation is Zn plus Cu2 plus gives rise to Zn2 plus Cu So n value you can easily identify, because any one oxidation or reduction equation you observe, the change is into. So F we can take it as 96,487, but for problems we can take 96,500 coulombs only per mole. And here they are asking standard Gibbs free energy. What is the formula for standard Gibbs free energy? Delta G equals to minus NF E naught cell, right? Standard means delta G naught. This is E naught cell. What can be written in this? So delta G naught equals to minus N value will be 2 and F value 96,487 into 1.1 is the volt, because Daniell cell, right? 1.1 volt is the standard electrode potential value. So if you simplify this, you will get delta G naught equals to minus 212.27. Mostly this thermodynamic formula related questions only come in exams. Very simple. Sometimes they ask delta G naught and later we have to find K value also. Log K or K they will ask, that is equilibrium constant. Okay, so that is one more model. If you want to find log K value, how do we find out? Delta G equals to delta G naught plus RT ln K, RT ln Q. So at equilibrium this K term will come. So at equilibrium delta G will be 0, then we can write it as delta G naught equals to minus RT ln K. This is the formula. So from that ln you have to write it as 2.303 log. Accordingly we can do it. Anyhow, that model also we'll discuss. So how to get this derivations also I have mentioned very clearly in the previous lecture. If anyone not watched, just watch completely in the before videos, so you get full clarity about derivations and the different things about Nernst equation. Neatly I explained, just once you watch, if not watched. Coming to next, calculate the potential of hydrogen electrode in contact with a solution whose pH is 10 and partial pressure of hydrogen gas is 1 atm. Just take the data from this. The next question is, calculate the potential of hydrogen electrode in contact with a solution whose pH is 10. So pH is given, which is 10, and hydrogen gas pressure is 1 atm, and E naught cell, E naught H plus 2 H2 will be 0, which is SHE. If that also don't know, you can watch previous lecture which is related to SHE and other points. Nernst equation, E cell equals to E naught cell minus 0.0591 by n log 1 by H plus, because in case of this what we can write it is H plus plus electrons gives rise to H2. So n value will be 1. So product by reactants, because you can write Q equals to H2 by H plus. So the concentration of hydrogen gas decided with the pressure, so that 1 atm by H plus, that's what we have mentioned here. Here we can also write one more, pH equals to negative log of H plus, which can be written as what? Log 1 by H plus. This is same as, wherever log is there base 10 will be. This is same as the above one, so which is given in this case. So in the place of log 1 by H plus, what can be written, students? E cell equals to E naught cell minus 0.0591 by n value is 1, and log 1 by H plus can written it as pH. So that's how we get the formula here. So E cell equals to minus 0.0591, instead of telling E cell everywhere you can write just E equals to E naught 0.00591 into pH, which is 10. So then what is the result? Minus 0.591 volt. This is the answer for this E, right? Because E naught cell value will be 0, that is for SHE. Hope it is clear.
Different question, right? So 2Fe plus 3 reacting with 2I minus converted into 2Fe2 plus I2. So E naught cell value is given at 298 kelvins. Calculate the standard Gibbs free energy and equilibrium constant of the reaction. So standard Gibbs free energy means delta G naught, which is N minus n F E naught cell, and equilibrium constant will be delta G equals to delta G naught plus RT ln Q. This is the base formula for this, but at equilibrium delta G naught is 0, so you can take delta G naught equals to minus RT ln K. So when delta G naught is 0, equilibrium, so at equilibrium Q becomes K. Q can write it as K. So what you can write, delta G naught equals to minus RT ln K. So you can also write this formula, delta G naught equals to minus 2.303 N RT, RT not N. So minus 2.303 RT, 303 RT log base 10 K. So here ln can write it as 2.303 log base 10. So first we have to do standard Gibbs free energy. Later you have to find log K from this. That too K from this. So you have to find K from this equation after finding delta G naught. So let us substitute first values into first formula. So the values are what? The values here is minus 2, N value is 2 because Fe plus 3 converted into Fe plus 2. So N factor will be 1 for each conversion, but 2 Fe plus 3's are there, so N factor will be 2. Since each change is 1 and involved ions are 2, so 2 into 1 equals to 2. Fe3 plus 2 Fe2 plus is 1 and 2 are involved, so 2 into 1 equals to 2. So N value is 2, Fe value 96,500 into, this is constant value, and E naught cell value how much is given here, 0.236. If you simplify this, what you will get is delta G naught minus 45,548 kilojoule per mole. So this can be written as minus 45.55 kilojoule per mole. This is the final answer for delta G naught. Now the delta G naught we substitute in this equation. So what you will get is delta G naught equals to minus 45.55 kilojoule per mole. Just that we can substitute in this equation, minus 45.55 kilojoule per mole equals to minus 2.303. R value is 8.314 into temperature is 298 kelvins. So log base 10 K is as it is. So in this case, what happens is log base 10 K equals to, you can just reverse this equation. 45,548 in joules we are writing by 2.303 into 8.314 into 298 kelvins. This is in joules value, so 8.314 we are taking. So log base 10 K equals to 7.98 is the value, and for this, from this we have to find K value. So K can write it as, here log base 10 is there, if you send other side it will become 10 power 7.98. This 10 power 7.98 can write it as 7 into 10 power 0. You can write this as like this: 10 power 7.98 can write it as K equals to 10 power 7 into 0.98 can write it as 0.9.6. Why? Because here 0.98 equals to log base 10 9.6. So 9.6 log 9.6 is equals to 0.98. That's why you are taking this, we are dividing. See, K equals to 10 power 7.98 can write it as 10 power 7 and log can write this as, so 10 power 7 into 10 power 0.98. So this 10 power 0.98 we will get log 9.6 equals to 0.98. That's why you can write it as 9.6 into 10 power 7 is the answer. See here once again, here K we can log base 10, K equals to 7.98. that can be written as, if you send this log base 10 here,
7.96.
1 minute. See here log base 10 K equals to 7.98. How to simplify this? This log 10 log base 10, if you send other side it will become 10 power 7.98. This can be simplified as like this. You can write that as 10 power 7 and 0.98 equals to log 9.6. So log 9.6 equals to 0.98. So in the place of 0.98 we can write it as 9.6 into 10 power 7. That is how we can get this value, 9.6 into 10 power 7. Simple. Log base 10 K can be written as 7. Log base 10 K we got it as 7.98. That can be simplified by sending this log to other side. It will become 10 power, whatever base value is there, that value with the power of this value. So that can simplify as 10 power 7 will write as it is, and 0.98 equals to log 9.6. So that 9.6 into 10 power 7 equals to K value in this. That's how we can simplify this log values.